Who is familiar with climate change risk assessments? Who's done them before? Any hands? Okay, a few, good, but most of you haven't. That's great, because I've had this passion. I thought, boy, people need to know about how the climate is changing. You know, there's a writer, Jeff Goodall, I don't know if everybody's heard of him. He was a Rolling Stone writer. He wrote a book about flooding, and then he wrote another one, The Heat Will Kill You First. And on a recent interview, he said, yeah, our infrastructure has been designed for a climate that no longer exists. Right? So it's not functional anymore. Things have changed. And what I might hope for this workshop is that at least they'll give you this fundamental basics, like you start thinking through. You know, it's not rocket science mainly, right? You don't need to be a climate change scientist. Maybe if you want to do some detailed studies. But at the very beginning, to try to say is, how is climate change going to affect my organization or me? That's what this workshop is about. Right? That's what I'm trying to do. So if that's me, and that's me, I think I look a little bit like that guy, right? So I founded Green Sky about 10 years ago. We're in our 10th year now. And just a show of hand, who is a kind of auditor or EMS type of background here? Yeah, quite a few of you. That's me, right? I was an auditor and EMS background working in businesses. And then about 20 years ago, close to 20 years ago, my boss said, hey, you know, we got a client who wants to work in climate change. And I started studying about it. And my mouth, you know, they say, you know, your jaw drop. Wow, I couldn't believe how serious this is. So I worked in climate change since about 2006. And that's mainly in the quantification and mitigation side. And about 8 years ago, I realized, you know what? We're not doing this fast enough, right? We're not moving fast enough. We're going to be impacted by climate change. So it's the adaptation side. And we're going to go over some of the ISO work that I've done, but ISO standards that talk about climate change adaptation. But this is what it is. It all begins with what I call the climate change risk assessment, but it could be just awareness, just thinking about it. So I hope this exercise or this workshop again will give you the chance to experience that process of thinking, okay, how is climate change going to affect my something? We're going to do a building as an exercise because we all know buildings. We happen to be in a building, right? So we can relate to buildings. And if you can do it for a building, you could do it for all kinds of different entities. You could do it for your company. Governments could do it. And at least get started. And then you can maybe sort through, well, the whole big picture and narrow it down, focus it and say, yeah, you know what? We need to hire somebody, like say a consultant. And there's more and more of these consultants out there doing climate change risk assessments. So that's what we're here to do. So, and we have, actually I have some handouts that have the slides, and we can, if you email me, I'd be glad to send it to you. So all the slides are going to be available to you. We have some exercises, but since this is all this information is available to you, I thought the most important thing is ask questions, right? I want you to be able to apply it. And if something by chance I say it doesn't make sense, go ahead, ask the question, let's stop, that's more important. But you will have a chance to actually experience in 2 or 3 hours today what might happen over maybe a few weeks or something like that, a longer process, like an actual workshop we might do in a half day or a day or something. It depends on how big the building or whatever that we're doing is. But there's some background, some homework we have to do. So we're going to look at some of that. We have a case study, and we'll deal with that later. And there'll be group activities. So 3 different activities, about 20 minutes each. The first part, a little bit of my presentation, and then we'll go into exercises. And the good news about it is that you'll be able to maybe stand up, move around, walk around during those exercises. So in basics, it's just a 3-step process. We can all remember 3 steps, right? Climate hazards. how's the climate changing? That's the first step. And that awareness alone will get you thinking. The climate change risk assessment part, yeah, we're going to focus on what I call a screening level, and maybe even before a screening level, just the awareness. You could get down very detailed, and so there may be some consultants that do very sophisticated climate change risk assessments. That's okay, but I think everybody, that may be good for, say, some organizations or some facilities, but everybody needs to have a basic idea of, in the organization, how's climate change going to affect us, right? So we'll focus on that part. And then the application or adaptation and applications. So there are things you can do, and surprisingly, most of the things you can do are very straightforward. And just by being aware, by thinking about some things that your company could do or organization, that will make a big difference. So I'm focusing on that part of it. Sure, there may be, you may need to build some piece of infrastructure like a dike or something, or some big, a new HVAC system, or that's a possibility. That's for other engineers to deal with. I'm focusing on the right up front, the thinking, planning. Maybe do you need a policy? Do you need a team? Or do you need some resources for that, a budget, for example? That's the kind of thing. So there's an exercise on each one of these topics, about 20 minutes each. So you'll have that experience. Oh, this is what you do in a climate change risk assessment, right? So yeah, I'm trying to make this just as flexible, as versatile as possible. It should apply to every one of you. And it could apply to you even in your home, right? So anywhere. Of course, we're going to take a building, but it could apply to anything. I don't think there's an organization in the world or a person who couldn't benefit from this kind of thinking. And that's why I'm delighted actually to have a chance to present that. The tools we have, I'm just showing you one way, right? And it's not really the whole thing, all the detail, but I'm just picking out bits and pieces, just so you'll know, right? This is something you can take away, and actually, they say on TV, don't try this at home. I say, do try this at home. Just think through, right? Sit down maybe at the dinner table. Hey, climate is changing. What happens if such, right? The temperature is changing, the precipitation. How's that going to affect us? You could do it at the lunchroom at work. How's it going to affect my school, my office, or you name it, my factory? Even anything, right? And then the infrastructure idea is that we're picking a building. How's climate change going to affect this building? It's just a piece of infrastructure. It has certain components. We call them like systems and subsystems. You could do it like we've done it for water treatment plants, water supply systems, wastewater treatment plants, roads, dikes, solar, wind farms, you name it. It can have any application. And you just walk through it. You can see it's a very kind of modular, if you will. You just step by step work through it, and you'll have the chance to actually do that in your groups at your tables. So yeah. I'd like to introduce you to ISO standards. Probably most of you heard of ISO standards, right? And ISO 14001, for example. Well, there's maybe a little bit of history. ISO benefits from volunteers around the world. And Canada is one of the more active participants in ISO, especially what's called the Technical Committee 207, TC 207. That's for environment, everything environment. And Canada has been the chair of that, as far as I know, forever, right? As soon as the Technical Committee was established. So Canada has chaired it and provided the secretariat. There's another subcommittee, 7, which is about greenhouse gas and climate change. So, not quite half, but it's maybe 2/3 of the standards are about quantification and mitigation. So greenhouse gas emissions and that side of it. About 1/3 are on adaptation. And the adaptation ones are the newer ones. So the whole business community has basically done the same thing I did, right? Start with quantifying greenhouse gas emissions and seeing how we can reduce them and then realizing, yeah, you know what, we're going to still have to adapt. And so they've got, these three standards. 14,090 on the right side is we call it the umbrella one. It is like 14,001. It has all the shalls, so it is actually certifiable. You could have you can get a certificate in it if you want it. And it covers the whole process of climate change adaptation. So from saying, just from the very beginning, I think climate change might be important. I should look into adaptation. This standard gets you going. Who needs to be involved? How do you prepare and plan? How do you do some kind of assessment? And they have a few different assessments: impact, vulnerability, threshold, risk. There's different ways of doing it. And then how to plan, how to implement, how to monitor your progress, maybe how to continually improve. Basically, it can be think that way, but it can be back and forth too. So this is the umbrella standard. Some people thought, well, you know what? Maybe we need a little bit more work on the risk assessment part, because if you don't know what your risks are, you don't know what you have to adapt to, right? So how do you do it? And in a sense, there's two parts to this standard. I guess the starting part is like the screening. So the people who did the EMS, if you've ever been in certification, how do they do it? They do a stage 1 and a stage 2, right? Stage 1 might be 1 or 2 days, visit the organization, and stage 2 might be 4, 5, 10, whatever days it needs. And the idea of the stage 1 is to get a pretty good idea so that you can plan and execute a really good stage 2, a really efficient one. So it makes sense, right? Just do a little bit of work to understand and then do a lot of drill down deep later on. And has anybody worked in impact assessments at all? Yeah. So in Canada's system, don't we have a screening level of assessment and then a detailed one? So not everything has to go through the whole impact assessment in detail. We go through the screening, right? And then even the ones that you've gone through and you say, no, it needs a detailed one, the detailed part of the assessment benefit from the screening, right? And so that's how this standard was written. Try to just get an understanding, identify what those climate hazards are and how it can impact maybe your infrastructure. So that's what that standard is about. The one on the left, 14,092, is almost like a case study of what 14,090. It's sort of like almost applying this standard, the umbrella standard, for governments, local governments, municipalities, that kind of organization. And they have a number of case studies, 5 case studies in there. I know one from Vancouver, and I forgot to look at the other ones. I think there's 2 from Canada in there. So again, Canada has had a big role in developing these standards. As a matter of fact, the first 2 standards are being adopted by CSA Group. And so there'll be a CSA standard, Z 14,090, Z 14,091, I think this year, 2025. So that would be available, Canadian version of it. Now these standards, one of the sort of problems is they're about $150, $200 each. So a lot of times people, but just think about that. If you went to a consultant, said, I want to buy $150, $200 worth of work, what do you think you're going to get out of them, right? This was written, each one of these standards is written by maybe a dozen of people meeting 3 times a year for a week at a time for 3 years to draft every word in there. And I'm talking about every word, every period, every comma in that standard. Plus, then back behind them, at least 60 government organizations like Canada, US, France, Germany, UK, you name it, and some developing nations too, reviewing each draft. So this might go through like maybe 8 different draft versions. And they got all this, 60, 80 people commenting. I know on ours, 14,091, I worked on that the full time. Every time we went to do a draft, 500 comments. 500 comments. It's the amount of effort that went in, I'm estimating at least a few $100,000 if you paid them. This is all volunteer work, right? So volunteers, you only get dedicated people working on these standards, right? And so they're very valuable. $500,000 and you can buy it for $200. It's the best deal. And you can buy all kinds of ISO standards too. Anyways, that's it. So this is what the 14090 umbrella, kind of a diagram or picture of it. And what's at the center? Interested parties. You know, that's like stakeholders, right? People who are interested, people who need to know. And the big thing about it is it should be a diverse group. Anybody's impacted. So for example, if you took this hotel, the owners would be in the group, right? Whoever designed the hotel, the engineers, the HVAC systems, all those people should have a representative. I mean, you know, you can't put them all in one big room, but somebody, a representative from the owners, a representative from the designers and the builders, maybe some local people. People have lived in Calgary all their lives and they know kind of what's going on, right, the climate-wise. And you get this group, maybe even First Nations people, get them all together in the room, sharing their perspectives. And that's a process for how you do a good workshop. So in a way, we've got that right here. At your table, you'll have a few people. Hopefully, you're a fairly diverse group. And you can see. But we'll be working on that risk assessment part. Some background. I'd like to give you some background about climate change. So if you look at this graph on the colorful one, the red, blue, and white, right? Red, white, blue. Hopefully you can see the green bell curve. Can you all see the green bell curve? That was climate before. That's maybe, you know, when I was a kid. Bell curve. Average temperature is happening most of the time. And then some of the extreme, you know, really cold only happens a little bit of time. And really hot is happening a little bit of time. That was the way climate was. But now it's shifted. And if you see how it's shifted, obviously it's shifting more to the right. So there's going to be more hotter weather. That's typical, right? But because the curve is not just shifting over, it's flattening down and spreading out. So before, maybe before we'd have like 2 or 3 sigma deviations. So really, really hot days and really, really cold days. So you'll see people say, oh, climate change, we've had really, really hot days before. We've had really, really cold days before. And if they're so cold, what's happened to climate change, right? But all that's happened is this curve is spread out. Now we're getting 5 and 6 sig deviations, right? Really extremes. But most of it being on the hotter side. And that's just temperature. Something similar could be done with precipitation. It's a little harder for that. Winds and those kind of things. But that's what we're dealing with. So imagine you designed your building for that green bell curve. But now we get this kind of temperature. How's your building going to perform? You know, I mean, the building might not melt or something like that or burn up, but how about the people inside? Like in Vancouver, I'm from Vancouver. Up until recently, no one had air conditioning, right? Nobody had air conditioning. Now people are putting in air conditioning. I think the same thing's in Calgary, right? Maybe you started a little bit earlier than we did. As a matter of fact, they tell us that by 2080, the climate projections say that in the summertime, Vancouver is going to have the climate that San Diego has right now. Imagine that. How many homes in San Diego have air conditioners? Like 100%. So that's what, you know, things they're going to have to change, right? Otherwise, we're going to be pretty miserable people during the summer in Vancouver if we don't have air conditioning. Or maybe better yet, heat pumps, right? Kill both, 2 birds with 1 stone. But okay, and then, so climate too, another point to tell you, climate is usually a 30-year period. So obviously, Calgary, we're in Calgary, has this climate. In Vancouver, we have a different kind of climate, right? And maybe Toronto even have a different climate. But when you're doing a risk assessment, you're concerned about the weather. Or at least when you design a building, you're worried about the weather, not the climate. You know, the weather. Are we going to get these kind of winds or these hailstorms or whatever? So you're designing for the weather. But we talk about climate change. It's a 30-year period. And interestingly enough, Vancouver right now is experiencing the same weather that Calgary is. identical. The only difference is Calgary is 1,000 meters up in the air, right? And you're colder than Vancouver, but we got the same weather. So even though we had different climates, so you just keep that in mind, that just because you have a certain kind of climate doesn't mean always your weather and your design parameters are going to be the same. Yeah, I talked about that. And then the one thing I say, that little highlight there, expect the unexpected. So how many times have you seen a weather story, even in Calgary, but anywhere across Canada, where you go, wow, this is kind of strange, right? Or it's kind of weird. I mean, just some of the ones that I remember, and it's not just Canada, but like in the US, Florida had bathtub water. So, well, they said 95 degrees Fahrenheit water in the ocean, down to 20 meters, right? It was really hot. That's like weird stuff. And you get on, different things like that. So expect the unexpected. When you're doing these studies, when you say, well, could this happen? You might have somebody in your group saying, oh, that's never happened. It can't happen. Well, yeah, maybe it can, right? Do you want to be prepared that you make that decision? Okay, so the groundwork, a couple of things too. When we have climate change, I talked about temperature, but you have like, what we really see, the temperature, precipitation, winds, that kind of thing. What we see are the effects, really, like sea level rise or wildfires or flooding or drought or things like that. So that's what we see, even though it might be temperature, it might be precipitation or whatever driving it. So we get these combinations. And it gets worse, like supposing we get a high temperature and we get low precipitation and we get strong winds. What do you get then? Like the LA fires, right? Exactly what they had. As a matter of fact, even before, they said last year they had strong, higher than average precipitation. That means undergrowth grew really well. But then they had a drought. Undergrowth started getting really dry, bone dry. And then, the spark and the higher temperature, higher than normal, and those big winds, boom. So those are the kind of things that you have to think about, those combinations too, in risk assessments. And then these cascades, was it 2 years ago, BC had the wildfires, right? And Canada had the wildfires, actually. I think it was the worst wildfires that we've had, like 3 times as big as even the worst ones. And 2 years before, we had, this is the record-breaking wildfire season. And then we had, even worse, right? So that kind of thing happens. But imagine you have a wildfire. And all the trees and the vegetation is gone. And then you have a heavy precipitation event. Loss of precipitation, flooding and whatnot. Mudslides, landslides, that kind of thing. So these kind of cascading effects will happen too. You can think about that as you're working on your risk assessment. Another thing I'd like to point out to you is most of us are linear thinkers. As a matter of fact, maybe that's what it means to be human. Right? We think we can understand 2 times. We can understand, okay, I'm here now, here's where I could be in the future. We really have a hard time to understand exponential. And this is what, but some of this is happening exponentially. So keep that in mind too. The workshop, let's say something about this workshop, is meant to be hands-on. So there's not a right and wrong. So if your table is going, well, this is going to happen, whatever, and you say, well, it could happen, well, speak up, right? I mean, it's not a right and wrong. Nobody's going to be graded on anything here. It's the experience. And one experience you're going to find is that people, when you work with, they see things differently. Sometimes does that mean, if they're not my view, it's wrong? I would recommend not taking that kind of perspective. In other words, well, he said that, she said that, maybe, right? Maybe I need to be open-minded, but share. Every opinion is valid. So do that. And then you're going to experience this over the next 2 or 3 hours. And again, expect the unexpected. So what are the steps? So we're going to walk through the steps in a climate change risk assessment. One thing before that. Well, why do it, or when do you do it? For example, screening level assessments or these risk assessments are really good when you don't have a lot of money or you don't have a lot of time, right? They're very quick. They get you going. So they're very good for smaller and medium-sized enterprises, right? Organizations. Maybe you don't have any specialists. A screening level is really good for that. Once you get into the detailed ones, sure, you might need a consultant. You might need other kinds of people who really understand what the climate is going to be like. Maybe people who understand how the infrastructure is going to react, right? By the way, there's ISO standards on infrastructure resilience and effects on climate change. You can look those up too. Sometimes, like the first step, I mentioned the stage 1, stage 2, or you start with a small thing, and then you can it'll help you focus on the detailed later. Maybe it'll help you screen out some of the less risky, if you think, well, that's not going to happen, so we won't work on that, but we'll focus on this. This looks like it could happen. We'll focus on that. So here's the steps that we're going to go through. First of all, you have to understand how the climate is changing. You might say, well, how am I going to do that, right? I'm an ordinary person. I'm not a climate scientist. You've heard people say that. I'm not a climate scientist. But you don't have to be, at least at the beginning. Just like maybe you don't have to know how to build a house to know how you want your house to be built, right? Or you don't have to be an interior designer to know what kind of colors you like or patterns or things. You say, yeah, that looks good. So that's where you come in, right? We're going to show you some tools that have this, where you can get the data. So you understand how climate is changing, and so that's part of the process. We'll have some handouts for that you'll walk through. So the first exercise is going to be on the climate. What are those hazards? What could they be? How does that look like when you see the different models showing that change? Then in the second part, we're going to walk through a risk assessment. Typical risk assessment, and try to calculate what that would be for a building again. And then we're going to do we're not going to do a detailed risk assessment. You can think about that, what that might be like, right? That would come after the screening one. And then the adaptation strategy. So the third exercise we're going to do is, after you've maybe identified some high risk parts, you think, well, you probably aren't, you're probably not going to tolerate or be comfortable with a high risk. You want to adapt. What can I do? There's a lot of things you can do, and you'll see there's some very simple things that you can do that'd be very powerful. Right? And I'm a big believer we saw artificial intelligence this morning, not machines, but people. I'm a believer in people and their systems, right? EMS, management systems in particular, right? So we'll talk about that. And then, the review, there's continuous support, the periodic reviews. That's something you could do later. So we finish the screening and level assessment. Maybe you do one back home. You go home and do that for your home or for your company. Maybe next year you do another one and you advance it, right? You get better. And then maybe the next one you get even better. Maybe you bring in a consultant to help you. All kinds of different things, right? And so it's a continual learning, continual improvement process. So we picked a building, again, because we can all relate to a building. In our case, this is a real, everything we pulled here is taken from a real climate change risk assessment we did. And in this case, it was a fire hall, so about 5,000 square foot fire hall, located in, it's Manitoba, but, kind of prairie type place, so not too different from Calgary. And we went through and did the risk assessment. So the altitude was probably like between Calgary and Edmonton in latitude, right, that area. So very applicable to you. By the way, how many people are not from Calgary here? Okay, so there's Eastern Canada maybe? Anybody from Eastern Canada? Yeah, okay. Yeah, so anyways, but most of you can understand prairie then, I think, right? So this is a good example of prairie. So the first thing, again, just as a refresher, we look at the climate data, and then we did that was something that we did as a consultant, but we did that, gathered all the data, talked to people, and figured that out. That maybe took a little bit of time up front. Then we organized this workshop, and that was the designer of the building, and it was the people who were going to occupy the building. And this was the First Nations, so the chief was there, the council were there, and people who had lived in that area for a long time. So we had that historical background. We had the operator, they know what they want for functionality in the building. And then we had the people who are going to be designing it, right? Building code and equipment and that kind of people. We ran the workshop, we facilitated it. And then we got the results, and there was some high risk and some lower risk. So anyways, we looked at how you could adapt to that, made the recommendations in the report, and that went off to the band. They had the report, and the consultants. This was funded in part, well, maybe all of it, by Indigenous Services Canada. So they're one of the drivers that asked for something called the Climate Lens Assessment. Infrastructure Canada, we're just doing one, or just finished one now, where it was actually Infrastructure Canada providing the funding. So different government organizations may provide the funding, but they'll all ask for the same thing, which is, I think it's the Climate Lens Assessment. Oh, yeah, I'll get there later. But some background on the fire. Just imagine a fire hall, right? They're not that big. This one, 5,000 square feet, maybe 2 stories or so. You got the fire truck. They got some resident places for the people to stay and live and cook and whatnot. Maybe some equipment there. Communication equipment. Yeah, you need to be able to contact the fire hall, right? So that kind of is a big thing. And yeah, so 50-year life. It's typical for a building. Some last a lot longer and maybe a little bit less. So we're thinking 50 years, we start 2025. Okay, that's 2075, right? So we had to look that far into the future. And there are data sets that project that far and for that particular area. And so you ask yourself, what's the impact for construction, operation? What considerations you might change this facility, how you might make it more than just building code. And of course, the building code is now the one that currently is in place. I don't know too many building codes that are actually looking in the future. Is anybody aware of a building code that tells you, start looking 30 years in the future? Does anybody know of one? Local level government, yeah. So they tend to be, this is how we want houses built now or buildings built now. And maybe even near future, but not into the climate change. And very, very few of them are looking at the physical impacts of climate change. So these are things we're looking at. And yeah, so we're going to do it like the exercise we're going to go into pretty soon, just a few more minutes. It's like a brainstorming. Again, not right or wrong. And the information we're giving you is not the whole. It's not all the information you can get from the data sets, but it's some. And you look at them and say, oh, I can see this. And you're going to pick out some of that and say, okay, which is the climate impacts that we're going to work on. So you understand that project. So things like, imagine the fire hall. It's not just the fire hall, right? But what's it standing on? What are the surrounding lands? Are they flat? Are they hilly? What grassland? Forest? So you have to understand that. Connecting roads. Fire hall could be perfectly designed, but then you go to drive your truck down the road, and now you can't get past that. That doesn't help either. So the roads that go with it. I mentioned the communication systems. How do you call? Hey, we got a fire here. That has to work. So all those little different pieces, of course they need water and the sewer and gas. It has to be heated. So all those things, those are what we call the subsystems of that fire hall, and we break it down. And in the second exercise, you'll see, we give you a part of it. The roof, the buildings, the envelope, that kind of thing will be in there. So we start off, remember again, we look at the hazard. So climate hazard, the future climate hazard, in this case, say at 2075, A lot of the data is broken down, like they have 2050, 2080, 2100. So, 2075 is close to 2080, right? And then we think about, okay, how's the climate change? You'll get those charts and graphs and you'll see, and maybe a couple of tables, and you'll see how climate's changing. Then you think, well, is that going to impact my infrastructure, my building? So you'll think about that. Maybe like, is it going to affect my roof, my windows, my heating, my HVAC? Then in the risk assessment part, we think about how likely is that going to be? And in my experience, when you look at a period like 50 years, that's a long time, 20 years even, the likelihood of some extreme event happening in that 50-year period gets pretty good, right? Pretty high. And so you tend to see likelihoods in the 4 or 5, and we're using a 1 to 5, right? You could use 7, you could use 10, whatever you want, but we're using a 5. That's what the climate lens process says. So 1 not being likely, 5 being almost for sure. That's the process. And then severity, the same thing. 1 being, yeah, so what? 5 being, yeah, wow, we're not working anymore, right? The fire hall's not functioning, or something like that. And then a simple risk, 4 times 5 equals 20. Okay, well, fairly high risk. So that's that part. And then we'll work as a mitigation. So that's the whole process again. And we're starting, the first exercise is going to be on that, the hazard, right? The climate hazard. And so at your, any questions to that point? So and we're going to hand out right now, at each table, you should have a package of slides. So if you feel like rather than trying to look across the table, why not just stand up, get together and look over each other's shoulders and flip through some of these slides. So we'll do that for about 20 minutes. And when you get there. But any questions about that process? So you're going to just go through. Yeah, go ahead. Yeah. Yeah, they're going to put it, yeah, they're handing them right now. So they're going to get the package out. Any other? Okay. Okay, so as soon as you get your package, look at them and look at the kind of information that's presenting, right? Usually it'll have a timeline and you can figure out where you are now and you can figure out what it's looking like in the future. And some of them are pretty dramatic. Sometimes, no. Oh. While you're waiting for the handout, let me run this little presentation here. Whoops, that's not it. Maybe I can't run the presentation. Are you able to run this presentation? Just a few short video. One of the data pieces is called Climate Atlas. Another called Climate Data. These are free data sets, and you can look at them as much as you want. But if we could run that if that works. Okay.
Although there are several ways to get to the information and data that you're looking for, one of the easiest is by location. Today, for our example, we're going to use Calgary, since that's where we're all sitting. As you'll see, it has information from 1971 to 2000, approximately. These are all the information that you will get. However, if you continue to scroll downwards, you will actually get things sort of as we discussed and looked at our examples. Hottest day. Here we can see the trends and has all the specifics as you go through. They are downloadable. Of course, the overriding Xbox are not available on those. One can download different ways. You can download the data itself, or you can download the graphs either in PNG or PDF format. The PDF format is exactly what you have in your hand.
Yes. You have the PDF handout, so you can take a look at it, and maybe you can pick out or think about how's climate changing, right? Can you see the difference? And what would you have to plan for? So think about your building, and with each hazard graph, figure out what might be the issues that you're going to be considering. Yeah. If you want to get up and move around, it's very nice. It's kind of good to get a break. Okay. So, can we get okay, good. Yeah, I noticed there's some of the graphs that are at the back, and at the front, there's sort of some of the tables. If you wanted, you could fill it in and try to see, well, yeah, is it getting hotter? Is it getting cooler? Is it getting wetter? And then how many days? And you can pick that out from the graph, right? So 2075 would be about your 50-year period. You can pick that out. Yes, sir.
data on the portal,
Oh, hey.
but it's not the same as the graphs.
Oh, you probably have to find the right same location, and we
That's
may.
Calgary. But did you use Calgary?
You know what? No, these are probably from Manitoba.
Okay.
Sorry, yeah, and that location in Manitoba too. But I mean, they're gonna be similar, right? They're gonna, yeah. But you're right.
It's really hard to read from the.
Oh, yeah. Sorry, yeah. Hi there. I think, yeah, okay, I appreciate that. Everybody's asked me the same question about the flooding events. Yeah, that was maybe potential for flooding, right? Or basically high precipitation events. That's what it would cover there. Excuse me. So, anyways, I think you've had an idea. You get the flavor. Imagine yourself in a workshop with, again, like say the designers, the constructors, the operators, the occupants, and you're trying to figure out this, and you're given these slides. That's what that exercise is, and you get more. Like if you went to Climate Atlas or Climate Data, you pick your location, you can figure out all the ones that apply. You can spend quite a bit of time doing that, right? But what we did, try to pick out a few, just to give you a flavor. And you notice how some things, I think temperature, like hot days, went really up, right? Did you notice that? They went really high. But what about precipitation? What did that do? Kinda, yeah. However, it doesn't mean that you're not going to have a change in precipitation, right? The peak events could still be quite high, and the low ones could be still low. So you can get some really big droughts. So you have to kind of read into it what you will. But our job as the facilitator, climate risk assessment facilitator, is get those kind of discussions. So how's that going to impact, say, the roof or the windows or the building, the envelope? And some people will say, wow, nothing will happen. The code is good enough, or the other way around. Oh yeah, wait a minute. If that this could happen, or they might say, oh, I remember the storm of 24 or 21 or whatever, such and such happened. And those kind of discussions, that's what we want you to do in the workshop, and then you start to rate. So the second exercise where you get to rate that, right? So does anybody have a burning desire to speak to a microphone and share some insights they had into that process? If not, that's okay, but if anybody would like to. No burning desires? Okay, fine. We'll keep going. And maybe we can finish early. So that's that. Yeah, so we see these kind of, the red one, by the way, is a more extreme climate scenario. And then the blue would be like, oh, we've mitigated a lot of our emissions, and the climate is actually not going to be that extreme. And then the different colors allow you to tell, which band it could happen. So, and which one are we on? I don't know. But what we do, we tend to pick the red one. So we tend to pick the worst case scenario and show you the most extreme possibilities, so that when you do your risk assessment, we're working in that area, and that will drive hopefully more reaction. Right? Oh, such and such could happen, because it's hard to project the future. As I mentioned, we're linear thinkers, but we just can't imagine really bad things happening. So that's one we have. That's what we do as a trick of the trade, if you will. And then, the data, we always look at temperature, how that's changing. That's an easy one to model. Precipitation is a little harder, but, I think Environment Climate Change Canada and climate scientists have got pretty good handle on that too. Some of the extreme weather events, that's almost a guess, not quite, but they'll look at, say, the worst case scenario and try to figure out, well, how bad could it be? It could be even worse. And then, droughts are hard to figure out. You sort of know you're in a drought after about 6 months. Oh, hey, we're in a drought. Like BC is in a drought. Doesn't mean you don't get any rain, but comparatively speaking, you get a lot less rain. It's a lot drier. I mentioned the LA fires, right? They had a big drought, almost 12 months of drought. Things burn more when that happens. Heat waves, again, you can sort of pick that out a little bit from the hottest days, over 30 degrees or sometimes over 35 C. But you can't pick out something like a heat dome effect. And I think Canada's, so far, the worst climate disaster in terms of fatalities was the one in BC, right? Lillooet. They had about a week of heat dome. At the time, they had the highest temperature ever seen, or in recorded history, in North America, other than Death Valley. And that was in BC, right? In Canada, hotter than Arizona, hotter than, pick your place in the US, right? But quite freak events. Heat tends to be the most severe in deaths. Free thought cycles, those are really bad for roads in particular, right? And they're just getting worse. But so those are the kind of things you could try to figure out. There's data for all of those. And you can see how that's changing. Are they going down? Is it going up? And yeah. So again, frost days, just an example. Our frost days are going down because it's getting warmer. Makes sense. And yeah. And so those tables that we filled out, this is what we came up with for our fire hall in Manitoba in 2075. So just look at that, right? The historical background, 7 days over 30 compared to 39 days over 30 at the projected case, right? That's quite a difference. So 7 days, maybe a couple hot days and then cooling down, a couple hot days, and then, summer's over. With 39, I mean, that's like half your summer, right? Hard to avoid is my point. And then the cold days, look at that. They still happen, and maybe 1 year, even in 2080, you might have 10 cold days, right? It's not saying it won't happen. It's just saying, the likelihood is going down. Yeah. Oh, there's something I forgot. We're going to have a lucky draw. So, lucky draw for this. So the next time we do an exercise, if you'd like to come, you can put your business card here. If you would like to get a book, you can put your business card. We'll do a lucky draw. And I'll tell you what this book is about. You can see these hands here, right? So if anybody's ever run a relay race, so the idea of a relay race is one runner is running as fast as they can, right? They're at full speed. And instead of just passing it off to someone who's standing still, the other runner is running full speed too, right? And they're just running like that, right? So they're both going at full speed. They grab baton, finish. And so that leg can be completed in a lot shorter time than if you're just standing still and had to run, right? So this is the idea I have for the book. My 40 or so years experience with not for climate change, but with sustainability. I'm kind of more of an EHS type of person, an EMS type of person. So I'm passing that baton. In this case, it happens to be the Earth. I'm passing that over to you. And this screening level assessment, the book is trying to get you up to speed, right? It's get you running at full speed, so you could do this too. The book is easy to read. It's a 4-hour read. No jargon, no technical stuff. Very easy, very simple vocabulary from a simple person. This is, I have an audio book. It's 5 or 6 hours, and you get to hear my voice. That's it. And the idea is that everybody, like my thought is, I feel like I'm a bit of an underachiever. Part of that problem is because I can't focus. When I focus on everything, right, I look at everything. So I have a difficulty there. So it's taken me 40 years to get where I am. But I've always felt, and I feel it sincerely, if somebody like you knew what I know, you could do so much more. Because you're smarter, you're better connected, you're better funded, or you're better at articulating, or you're more persuasive, or you've got an organization behind you. If everybody would know that, then basically, I'm not saying everything I know is in here, but probably a lot of it. Everything about climate change, anyways, is in here. There's some nuggets in here and a process. What this book gets you to is like an ISO 14001, except for climate change. There's a system. So you'll develop a management system. Sometimes like you've seen a manual, right? EMS manual. So the last two chapters chapter 8 tells you how to build a management system. And then chapter 9 tells you how to use it. But the whole book kind of builds you up chapter by chapter, how to do context, how to do planning, how to do target setting, and different things like that, all about climate change. So, it's not a big deal. It sells for a few dollars, and the royalties, 100% of the royalties go to a solar project in Africa. So I want to do a solar project. I don't make any money off of it, but hopefully we can see a solar project in Africa being built with the results of this book, ideally. So that's the lucky draw. So next time you go into the exercise, if you want a copy of the book, drop your card off there. Okay, that's a little bit of advertising. So exercise 1, we did the exercise. I apologize, I should have done this earlier. That's what you just did. And now we're going to look at the exercise 2 part, right? Once you have an idea how climate is changing, then you move into, okay, yeah, please go ahead and handle this out. You'll start, okay, how do I do that risk assessment? How do I determine which hazards are low, which ones are medium, which are high, kind of thing. So there'll be some probability scales, likelihood, 1 to 5, impact scales or severity, 1 to 5, and then the risk matrix. So there's a little table and has a subsection of some of the subsystems like the roof. I can't remember what else we put in there, roof and walls and something like that. So you'll be able to actually work out, and you can put some numbers in there, 1, 5, 10, something like that. Yeah. So again, severity, 1 to 5, maybe that's good enough for some of you. If not, very low to very high, or measurable to serious, measurable impact, barely noticeable. Serious, okay, maybe loss of function, doesn't work. Now my fire hall, we can't access it, that kind of thing. So there's different, say, criteria here, and each column may resonate with a different person. Somebody might like the numbers, somebody might like the detailed criteria, and somebody might like, the middle, in between. So that's just there for your reference, and you could have more. Quite often people talk about dollars, so they maybe have a dollar impact there. And then the likelihood, very low, very high. As I said, when you have a 50-year time period, the likelihood of anything happening, in my opinion, is very high. You may disagree. Maybe some of you do a lot of this kind of work. You may see it differently, but I think it tends to be like 4 and 5s. If anybody tells me the climate change, 1 or 2 for a 50-year period, no, I don't buy that. But I could be wrong too. So that's the likelihood, and then you get this. So that's how we work it. So red tends to be high risk, right? And you probably want to mitigate that. The more blue and green the colors, those are, maybe you can live with it. Because you can't deal with everything, right? But you can live with that. So that's what you'll get. And then from there, you'll be able to figure out, do you want to mitigate? So here's a table we use to figure out what the likelihood is. So if you see, for example, will this interaction change? Like if you have the first one, drought, extreme heat, how's that going to affect your building? Or cold weather, how's that going to affect your building? Flooding, how's it going to affect your building? Well, yeah, probably. And so this is how you come up with the likelihood. This is what we came up with for this particular building. And you can see even precipitation hail, they thought 3. Partly it was thought of a 3 because no one's ever had that happen. This is Manitoba, but it doesn't mean it couldn't. But you see the other one, 5. For sure, they're going to experience a drought. For sure, there's going to be wind gusts, maybe even up to tornado level, right? Almost for sure. High likelihood still flooding and cold weather. This place happened to be close to Lake Winnipeg, right? Pretty flat land there. So yeah, likelihood of flooding much higher there. So you have, I think you'll have something like this to fill in, or anyways, that's the idea. You will figure out the likelihood, and you will figure out the severity. And again, it's not like a right or wrong, but it's just what you feel at your table. Again, sort of a brainstorming, you come up with something. And this is just to show you, so you have a climate hazard like temperature. Now, is your infrastructure, say a roof, is it exposed to the temperature? Yeah, it's exposed. Is it sensitive? You know, maybe not. Like, is a roof, it's not going to melt. It's not going to start on fire. Yeah, maybe there's some problems. Maybe something you could do with it to help. But if it's exposed and sensitive, then you're going to come to, the hazard is going to have an impact, right? And that'll be the impact. The red is the impact. And then if you come up with adaptation measures, that will bring you down to, that's what we want to do. We take a big hazard, drop it down to a little hazard. Well, a lesser hazard, right? And use some kind of adaptive capacity. So this is what, that'll be part 3. And this is your risk matrix. You're going to get a piece of this, not the whole thing. But here's how we set it up. So we would walk through the drought, and then take a drought, walk through all the different infrastructure, take the cold weather, the flooding, and walk through all the different infrastructure pieces. And you see there's a column for impact. So impact means like it's a yes or no. Like if there's no exposure and it's not sensitive, then there's no impact, right? But if it's exposed and sensitive, then you have an impact. So it's yes, no. And then the likelihood, 1 to 5, probably 5 or 4. Severity, okay, 1 to 5, whatever that is. And then you multiply it out, that gives you the risk. And usually and we do that at the table, like in the group. What do you think? And we get some debate, and then we come up with the numbers. And then say it ends up at a 20. That's pretty high. Then we talk about, okay, what could we do? What do you think we could do to lower the risk? Say it's a roof, well, how about we made it out of metal instead of, shingles, or instead of a flat roof, tar and gravel or something. What would the metal roof do? And they could talk about that. And with HVAC, well, yeah, we didn't put air conditioning. We thought we'd just leave the doors open normally. But no, maybe we will. And maybe we'll do a heat pump. So we'll talk about those kind of things in that notes adaptation part. So you'll have a chance to do that for maybe a couple of, not the full, I don't think we didn't photocopy the whole bit, but we gave you a little bit. And so that's it. Yeah, your turn. So go through that. Anybody wants to have your name in a draw, you can put your card there, you can get the book. We'll work on this for another 15, 20 minutes.
No, it's mostly open field, but there is more forest spaces. But yeah, there's forest fires everywhere. This is probably talking about forest fires. So yeah, forest fire risk is should be more snowfall. They're getting milder. We're having less days. just a few really intense rains. And it'll be really dry all season. And then winter, it'll be no snow or a lot of snow. So that's not let's say freeze thaw cycles.
So that means we say once we say yes, it be freezing.
Like concrete floors being cracked.
This is yes or no. It's not like each impact is. Oh yeah.
You like to see what's going on.
Getting
Groundwater,
years.
There's less cold days
we
every
weren't doing much to I don't know what this tells us.
freezing and drying, so maybe it will.
Just being cloudy.
Yeah, because
It would affect it, yeah.
And it can be caused by business.
And like, even your roof structure may actually be impacted. There's a lot of rain.
That's what I mean.
It can't collect all of it. It's gonna cause blockages in your drainage.
So precipitation going up, so yeah, we
It
should
can
say
become
yes.
critical within 10.
What about building envelopes on the side?
Prairies you need these
Yeah,
the foundations crack. These crack.
I would say the risk is like
Oh yeah. And like,
very high.
yeah. Likelihood for the flooding to impact them. Quantify it.
I would say it's the same as the likelihood. I would say no.
I would say high because I expect winds, spots on the sea, flat roofs, and just like precipitation. Sitting on flat.
You say the same as
Okay,
I would say 50.
yeah.
there's less specific.
how would that impact
Yeah.
fabrication?
Although we're talking about cold.
Yeah, exactly.
So maybe no. Maybe not. Yeah.
I would say yes in terms of expansion.
Building stuff around them so that they don't see the and then like now
Make sure. Or maybe like thinking
Your parking lot is probably more likely to get flooded, right?
I'm just picturing anything the hospital.
Oh yeah.
Sidewalks are that now.
because it's increasing flooding. Oh, that's
So there are a couple of like that
Yeah, it's softer.
and then there's also
it's still like
yeah, Lucky Stone, but it's active. Yeah, so it's just
No, I'm like, I can't.
Too much coffee. Oh, coffee. Site selection is a huge one.
it's a foundation.
yeah. Really lost.
That's what I was going to
Likelihood of severe
Okay. How are you making out? Would anybody want to present any results? Again, you don't have to. Any burning desire to present something? Yeah. Okay. Here. Is there a microphone? Somebody can bring the microphone to her. Yeah.
Okay, so we worked through a couple of examples, so we just all the way through. So looking at something like the roof structure, for cold weather, we did say, you know what, there is going to be an impact with our ranking likelihood of 5, and then we came up with 3 for severity and a ranking overall for risk for 15. Some of the adaptation measures is obviously the design of that roof structure, considering the angle for how you can, capture the rays of the sun and things like that, as well as snow shedding and insulation. And I mean, that's cold weather and hot weather, but yeah, they are value. For, let's say, precipitation on that roof structure, yes, it will have impact. We had 5 and 5 for likelihood and severity with a 25 rating of risk. And in there, we were talking about things like, because this is hail-resistant materials, again, the angle of the roof for allowing that hail not to accumulate and bounce off. So those were a couple of the mitigations. And then on the flooding side, though we didn't think, it's a roof, so it's probably not going to inundate the roof from a flooding perspective, but now we were concerned about conveyance and trying to get that water and where is it going to go? So we were thinking the downstream, are we going to collect it? Are we going to have retention, especially if it has a large roof surface? So those were some of the things we thought about.
Yeah, interesting, very interesting, great job. And like first thing I thought of, well, you could put a cistern in there, right? Or how about nature-based solutions? I think we were talking about that at one of the talks, right? Maybe a wetland or something like that to absorb that. Yeah, great thinking. Anyone else want to? I mean, you got to the idea, and notice some of those adaptation measures. Were they like talking about spending huge amounts of money, like something different? No, I mean, just some of the things are just at the design stage, anyways, are mere tweaks. What kind of roof material or what angle, which direction to point it to. I mean, that almost doesn't cost you anything. Which reminds me of something. Everybody remember the Fukushima reactor disaster in Japan, right? So I saw a National Canada Film Board and Japan Film Board joint thing on this, and they studied it. And so what happened, of course, 10-meter high wave tsunami came crashing down, right? Well, the reactor was designed to have a wall around it to prevent that kind of thing, except it was only 3 meters high. So more than they had anticipated. The real problem happened because they lost power. But the reactor was designed to have a backup power system, full generation, so they could have handled the event. The problem is, where was the generators? Located in the basement. So the flood, 10 meters of flood came in, inundated, everything flooded, backup generators go out, nuclear disaster, right? $600 billion problem, and maybe rising even. It's still going on, right? $600 billion problem. How much do you think it would have cost to design that reactor with the backup generator built on the 3rd floor instead of the basement? Like, nothing, right? Basically, nothing. So it's just a simple thing like that. Like if they would have thought, well, wait a minute, we might get a 10-meter wave on a 3-meter wall. I mean, say, should we build a 10-meter wall? Or maybe they could have thought, how about we just put that backup generator on stilts or something like that, right? Or build it on the roof or whatever. And that doesn't cost any money at the design stage. And even a retrofit, how much would it cost before the reactor disaster to have changed the generator to a 3rd story, right? $1 million maybe, a few $1 million. $600 billion disaster could have been prevented. And there's a lot of these simple things, just changing something, particularly at the design stage. That's the time to do it before any money's been spent, right? But even in the retrofit, just thinking through some things that could be done. And some of those are policy things. Right? So anyways, that's just it kind of triggered a thought about that. So we're doing the risk. What we got was, if you did the whole thing, like, so there's 5 different climate hazards we looked at. And, the whole system, much more than you had there. Roof, the envelope, the roads, the communication, the HVAC, utilities. So we went through all this. We came up with this. So out of, we picked 40 potential scenarios. 6 of them we thought were high risk, extreme high risk. 7 at high risk and so on, right? So the extreme high risk, 20 to 25. This is when you have very high likelihood, and then 4 or 5 in the consequence, right? Very, very severe, maybe to the point of loss of function. So that's what we did. So we have these, and now you have to figure out what you're going to do about it. The adaptation part in your group that you did is exactly what we do in the workshop. And I mentioned it's like usually half a day. It might extend to a day. As a matter of fact, bigger systems could go on for days and days, right? You might do that. But so for a building, half a day is quite a bit. You can get through a whole building. And so they started talking about some of those adaptation. And then we went back into our desks and said, as the climate change facilitators, said, okay, what could we recommend, right? What makes sense? And so this is what we're going to get into the next exercise. So adapt to change, right? How can you adapt? And so this is what we came up with. Just a few. Maybe I can stand over here. It might be easier. Okay. Enhanced design. So a lot of the designer people would say, well, it's built to the building code. And well, the question is the building code adequate? So the team, with the people we're working with, they said, well, maybe we could go beyond the building code in a few cases, right? Like adding on more insulation, maybe that's beyond the building code, but you do that. Or make a steeper slope, right? Maybe the building code doesn't require that. So that's the kind of thing they did. Moisture barriers, because in our case, we're considering flooding. So moisture barriers there made sense. High temperature tolerant equipment, their power system and HVAC, and so something tolerant for the higher temperatures. I think maybe one of the designers may have been the electrical engineer who said, oh, these have a threshold of 40 degrees C, right? They're spec, 40 degrees C. You're saying that maybe we're going to get some 42? Oh, that's going to be over the threshold, right? We need to redesign. That kind of thing could happen. Mechanical, electrical, located second floor instead of the first floor of the ground, right? Get anything up. As a matter of fact, I told you I was 5 years ago, I was traveling as in Fort McMurray to do a climate change risk assessment. It was for a Métis Nation. As a matter of fact, I think the project's just about, well, if not finished, just about finished. It's beautiful design. I was concerned it was on the Fort McMurray River, or whatever river is going through there. It may not be called Fort McMurray River, but whatever that river was, it was on sort of an island there. I said, you get flooding. But they didn't own any other land. What are you going to do? So they could say, we don't build the building, or they decided they're going to build a building. But it's 2 stories. And they said everything important, like artifacts, records, paintings, anything of value was on the second floor. On the first floor would be things like meeting room, like this, or people gathering area, right? Okay, well, if it gets flooded, you have to clean it up for sure, but it could be replaced, right? It's just furniture or wall painting, drywall, that kind of thing. So everything on the first floor was replaceable. The valuable stuff was on the second floor. So the chance of the river flooding that bad that it got to the second floor was, very, very small, right? But that's one of the things they did. They had, what did they have? They, like wetlands, they didn't call that swales, and a bunch of things like that. They designed it. The architects were already planning for this stuff, but when we did the risk assessment, part of it was embolden them. Yeah, we need to build a bigger wetland system to handle this, right? And so they were in Bolden. It's a beautiful project. If you look up Fort McMurray Métis Cultural Center, I think that's what it was. It's beautiful. It's in a kind of, the infinity loop, right? It's made like that, kind of two circles, and it has something significant with the Métis people there. And it has many of these kind of features. You can see solar panels, heat pumps, all kinds of features. But those didn't really cost the Métis nation more money, right? It was all within the budget. It was just because they had the time to think through some of these changes. So this is, again, why I think it's so important for you all to go through this kind of exercise, just thinking through, oh, what can we do? So the next exercise is really quite interesting. We think about the adaptations. Those are the ones we actually did, but there could be a lot more. And I want to talk about something called adaptive capacity. That's jargon, right? It's just the ability to adapt, or, tools. Most people will talk about financial. So a big company tends to have a lot more money or access to money. They can get a loan, or they even have enough money themselves. They have insurance. Right? Those are financial tools. They'll help you. Like if you get flooded out, no problem, rebuild, right? That's the kind of idea. And in the US, you get FEMA, right? So all these disasters come along, government gives more money, and they rebuild. Unfortunately, they're building back to the old standards, right? Rather than something new. Or even, no, we're not going to rebuild here. We're going to go somewhere else. But that's tough. But anyways, that's the financial one. The technology would be things like maybe a dike, or maybe the cistern, or maybe making your roof different material, or making your envelope more insulation. The technology, usually it's not that high tech, but there may be some technologies, heating or heat pumps, that could apply. It's kind of a know-how, but a technical know-how. Another one we talked about, ecosystems, nature-based solutions. Those are very popular, and I think those are very helpful and effective, because something like a wetland can absorb a lot of water and then give it back at the right time. It's give and take. One thing to caution you about nature-based solutions. Remember that chart, you have that climate hazard. Exposure, yes. Nature is 100% exposed to the climate hazard, right? By definition, it's out there. Is it sensitive? Well, it can be. So, for example, if the trees that are part of your nature-based solution are sensitive to high temperature, you need to change those trees, right? Different kind. You can pick those species. Or maybe don't take trees at all. Take mangroves or weeds, bulrushes, or different things, right? So you have to be careful about the sensitivity. You can adjust that because it is exposed. The other one I want to point out to you is the organizational one. And a number of you said you were familiar with EMS, right? ISO 14001, or even the quality management system, or any management system for that matter. It's about the organization having the ability to plan, do, check, and act, right? And so any company with a 14001 management system, like I was just talking to Stephen, he said, City of Calgary is certified to ISO 14001, or at least has a management system to that. Okay, they have an ability to plan, do, check, and act, and improve, right? Get better all the time. So apply that to climate change. And now you have an ability to do that. And part of that plan, do, part of the planning part, I think, is capability and awareness. So just being aware. That alone, if your organization, just imagine if your organization, most people were aware that, for example, high temperatures could come, or high temperature and high humidity. Oh, it could be unsafe to work outside. Different things like that. Just being aware. Then they could, through suggestion box or other means, they could say, hey, here's something we could do, right? You can enlist the power of all those brains, right? And I think maybe even better than AI. They can propose solutions if they're just aware. Like if you don't know, wow, you can get caught off guard, right? So just the power of just being aware. Educate, run some of these climate atlas or climate data, just go through some of them. maybe once a week or every now and then, just show, maybe post some of these. Here's how climate's going to change, and get people thinking, right? So awareness, maybe have some, if your organization needs it, maybe some specialists, right? Climate change risk assessor, you know, that's your role. You know, you're going to be championing this for our organization, making sure, the boss, top management, giving some budget, right? Giving some time. Okay, once a month you're going to meet and we're going to do this, and I want you to report back to me, you know, at some frequency. I wanted you to develop a plan. What are you going to do? Who's going to do it? How much is it going to cost? All these kind of things. They're not, again, not like technically difficult, and they're not really expensive. That, I think, is one of our biggest tools for climate change adaptation. Not some of the things that you read, like, oh, we're going to build dikes and we're going to build cisterns and we're going to build all these things. You might need some of that, but just the know-how, the management system. So I call that organizational adaptive capacity. So now you have a turn. So going through, you could pick out the ones that we identified, or you could pick up the ones that you identified, and then go through there. Like this group's already figured out some adaptation measures. Think also about some organizational, you know, adaptive capacity. What could you do? Training people, making them aware, hiring, maybe having a contract with a contractor who could come in and do something for you, right? Clean up or pump out water or whatever, bring in backup water supply, those kind of things. In the time when there's no emergency, plan for the emergency. Right? That's when you need to do it. When there's an emergency happening, boy, it's really hard to think. And that's sort of what happened with COVID, right? COVID, let's do this, you know, and well, they did some good things and maybe some not so efficient things. But if we could have planned for it beforehand, like Bill Gates was saying, plan for a what do you call it, a virus outbreak, because it's going to happen again. That's when you do it, right? And it's not that expensive. So you're in your team, you got another 15, 20 minutes, just talk through some things, and particularly think about some of those adaptive capacities. And then we'll get together and share. Yeah, so off you go. Another 15, 20 minutes. And again, if you want to book, we're going to do a draw.
Probably like a sump pit and a sump pump for flooding, to pump out flood water. Those are basically the songs and buildings, I'd say. Yeah, it's a good idea. Just because we're going to see
Actually, they had that in Victoria too. When I was in the bill, they had like a little outlet that if there's a backup, if the sewage flooded as well, then there was like something that was that's what's interesting, like a lot of new builds in DC have the outfit for solar panels. But then you come to Alberta and not a lot of new builds have that. Maybe not all, but at least like you still have to
So having a heat pump would be good to save energy, and it also acts as an AC. Roofs? That's so cool.
yeah, thank you. It's like the rainwater collection, right?
So that kind of like.
Really?
Huh?
So I thought there's some reason it's illegal to
Yeah, I think so.
Really?
where they don't want
I didn't know that.
Disrupt
their
the
own
hydrology.
or have their own source of water.
Yeah, what the hell?
Like in Canada?
Oh,
Yeah.
the States. Oh,
Oh yeah.
Yeah, I think so. I feel like it might be where it's BC. Like,
Well, I had a friend, her dad had built a cottage on the island. It was like a small island.
I was fishing right next to it.
So he made it in the 80s, but he added rainwater collection. Oh wow.
So having a building envelope would be good.
That's neat.
Oh yeah, right. Like that's a membrane. Like an impermeable.
A lot of buildings are now going towards like steel, wood, and concrete. They're doing mix.
Oh,
I see it like mostly residential, but mass timber is good too. But it's expensive.
yeah, that's what to consider. Is our building going to be made out of concrete, steel, wood? Whatever's less flammable. Concrete.
Yeah.
Shouldn't be.
wood if it's a fire.
Oh yeah, so it's gonna be concrete.
Maybe also like smaller fire trucks in the future. Well, because like, I don't know enough about fire trucks, but is there a reason that they're so big? Because you're tapping into a fire hydrant.
Long range.
Yeah. Yeah.
Their outfits. What underwear? Smaller fire truck. I like it.
Where all the
Oh, right, so that they can actually get to like a
and all
yeah.
their like makeup is to make them and their pretty special.
Oxygen.
It's all of us.
Okay, it adds up.
So we'll keep the fire truck clean.
Yeah, hybrids, right?
We should have
Yeah.
outside the building. There should be some green space. I mean, plants would work. There are some species that are like like sidewalk tiles that look like this, where there's many plants around to allow for better water infiltration. Yeah. Sure. Yeah, that'd be good. Yeah, help having some sort of education. Fence. I don't know how the
Be like fire, repair fence made out of wood. Easier to be
metal fence.
metal, like fire screen fence.
I think we're just metal.
Or even to like follow wind. Yeah, maybe the fence is an added cost that's not required. That's true.
don't know what the site looks like. So whether it would need a sewer tank and a septic tank to be connected to the other side of the water. Yeah. I don't think so. We don't know if it's a rural or an urban setting. Oh, yeah, good point. Yeah.
The 2014 flood. I think there was some sewer stuff that ended up luckily we get our water, like it all comes from the mountains. It's all going down. So it comes down, take out, pump back in, down. We were at the end.
Okay, how are we doing? Hopefully you figured out some adaptive capacity and ways to lower the risk, whatever it is, right? You always want to make it lower or more tolerable. And let's see what we have. Whoops. Oh, it doesn't seem, the slide advancer doesn't seem to be advancing. Oh, yep. It doesn't seem to be working. No, still not. Oh, here you are. Yeah, oops. No, I went too far. Okay. Enhancing adaptive capacity. So that's what we talked. Does anybody want to share any of our ideas? Like we already had a few over here, but anybody else? I love the simple ideas that actually have a lot of impact. Anybody think of any? Anybody want to share? We can bring a microphone. Yeah, okay, this table over here. Hang on, there's a microphone coming.
Thank you. Okay, so this is for a fire hall in the prairies, right?
Yes.
In an urban or a rural setting?
Pretty rural, fairly rural, yeah.
Okay, so there's a septic field and septic tank?
Probably, yeah.
Oh, okay, that changes things a little bit. Okay, so with precipitation increasing, the building should probably have a sump pump installed just to pump water out of inside the building. In cases of extreme precipitation, there's going to be pretty intense hail, like snowball-sized hail, so it'd probably be good to have a peaked roof. And like short, intense rainfall activities are going to increase, so having peaked roof would be good to help direct that storm water instead of it pooling.
Okay, so that involve equipment, right? Like pipes and pumps?
Yeah,
Pipes and pumps?
downspouts and
Okay.
having a heat pump / AC would be good because it saves electricity and we're having more days above 39 degrees and fire hall workers work hard, so they're gonna be sweating anyways. We don't want the building to catch on fire, so it would be made out of concrete or brick, not wood.
Yep, fire hall. You would hate to have a fire hall burned down.
Yeah, no wood frame. Having good drainage features such as a little bit of green space, but not like trees too close to where the fire truck's turning around. And having like drainable sidewalks where native vegetation can be planted in it's like a crisscross of concrete and to increase stormwater infiltration.
Great.
And then probably no fence because fire trucks are big. You don't want them to run into too much stuff.
Okay, great. I think one of the things we related to that, to the flooding, was could you build the fire hall a little bit elevated
Yeah.
somehow,
Spot
like
selection.
elevated ground, right?
Spot
That kind of
selection
thing.
for sure.
Yeah, and of course, we didn't tell you in this case. I don't know. I can't remember how much land they had, right? Like if they had a lot of land,
Sure.
maybe some of those nature-based solutions would be more applicable. If they were just like, say a small town and the next door neighbor is right there, you have a lot less you could do with, say, some of the nature-based solutions. But yeah, great. Anybody else want to share any ideas? Yeah, over here at this table.
Thank you. We started off by talking a little bit about educating the context of why we were going to do this for the top decision makers. We tend to find that a lot of times you come out with this plan and they just kind of look at it with deer in the headlight eyes and they don't understand it, which makes the job even that much harder. But we thought we'd start off by educating the context of it and why is this important for the building to get the money and that sort of stuff.
Great. That's a great suggestion. Yeah, make it effective right from the beginning.
Because of the weather and things like that going on, we thought about looking at for the firefighters and that sort of stuff when they are having to go out, re-looking at their innovative design for their clothing, just so that some of the other measures we were putting in place could really work. Maybe from an electrical perspective, if you're putting something that's going to increase the electricity demand in the building, is navigating the roof in such a way that you're maximizing your solar capacity, put solar panels on it to give you some more electricity generation, offset some of that there. Use low impact density installations or lids, and nature-based solutions around the water drainage from the ceiling or the roof and all that sort of stuff.
Oh, some great suggestions, yeah.
A different siding for the building, again, going back to make it out of something that isn't going to burn and that's not going to damage easily and last for 1,000,000 years.
Right.
Insulation upgrades, make sure you got a really good insulation in there to keep the temperature cool in the summer when you're applying it and warm in the wintertime.
Like even a passive house type thing, yeah, or towards that, right? Yeah, great. Yeah. Oh, perfect. Thank you very much. I appreciate you sharing on that. Yeah, one thing. You sort of we implied it. I said it was Manitoba, right? So Manitoba, what does that mean? Clean electricity, right? They have hydro. If it was the same kind of project in Saskatchewan, it would be a little different. Of course, they wouldn't have Lake Winnipeg beside them either, right? So the location is critically important. What might work in Manitoba might not even apply to Saskatchewan, might not work in Alberta. So one thing about these is they have to be repeated for the specific project. And that's why, I think it's not like you get a formula, plug in all the variables, crank it out, and now you got the answer, right? Everything is so case specific. Is it a new design? What's the life of it? What else? Yeah, everything's going to be unique. So you can maybe learn a little bit from a previous one, but that's only going to inform your thinking process. But most of the people doing this, of course, we're doing it again and again, so we're learning as we go along, but most of our clients are doing it for the first time. We had a couple of the consultants who had worked on it for the second or third time, right? Maybe designing a water treatment plant or whatever. But often the lead designer was different, right? So people are often coming at this new. And so we're trying to educate them and all that. And I think your suggestion, like educating who's going to get that plan, why this is important, that's critical, right? Which again, I think that's part of that organizational management system. It's not doing with money, it's not doing with technology, and it's not eco-based systems. It's that organizing, if you will. Anybody else want to share any ideas? I'm sure you have some great ideas. And, but yeah, it's okay. Well, here's just some ideas I thought, just further on that adaptive capacity, organizational level. So, for example, just having clear roles and responsibilities, right? That idea, who's doing what, and then somebody can maybe spend a little bit of time of their job to get more aware, right? They're aware. Having leadership. So say the organization even recognizing, hey, this is going to be a serious problem. And it's not just, especially for organizations, it's not just for them. What about their supply chain, right? That's a big thing. And when we had those supply chain disruptions, remember, just after COVID, I don't know if it's coincidental or it was related, but yeah, things weren't happening. And so I remember, and also like little parts, critical parts, weren't getting in there, and now whole cars aren't being made. Right? Well, one of them was I don't know, certain semiconductors were missing, or the wiring harness wasn't being made, and different things like that. So you have to look at your supply chain. Your organization may be really resilient. And if you could remember that word resilient, remember, like you could be resilient to a disease, or resilient to economic strife or war, or whatever. What we're trying to do is make resilient organizations. And that know-how is helpful. Having these roles, all this stuff is in the ISO. Like the standard will tell you, you should have somebody this, you should have a communication plan, you should have all these roles and things like that. Yeah, competencies is basically training. You might do training, but what you want is competency. Keep that in mind. Effective internal communication, yeah, what you're saying to people. Some companies make critical material, so you might want to be communicating that, not just to your supply chain, to your customers, but maybe even possibly to the government, right? That kind of thing. And then, like if you're say the power authority, the utility, these guys, as a matter of fact, I mean, the utilities, especially, we depend, as the speaker said this at lunch, right? Wow, what if electricity went out? Like, we're so dependent on electricity. So whoever's responsible for electricity should be doing climate change risk assessments totally, right? I mean, I assume they are, but they should really be doing it. And it gets complicated for them because they're everywhere in the province, or maybe sometimes they depend on interactions from other provinces, from the states to the states. So yeah, that's a big market for them. And then, yeah, continuously monitoring the situation. So you did this screening level assessment, maybe you figured out, okay, that half is not that important, but this half has a few, you do some more detail here, and you keep monitoring, and then maybe, you find out one or two of these things, turns out, yeah, like you heard about something happening at a similar facility by another company. Oh, maybe it could happen to us too. Boom. Because as we said, expect the unexpected. How do you think about something that's unexpected, right? Like, was that Rumsfeld said? You don't know what you don't know? Yeah, very obvious, right? You just don't know it. That's by definition, you don't know it. So it's hard to think about these things, but you might hear about it happen to someone else. Safety is like that, right? If you hear a company has a safety incident, well, you should think about that. Could that happen to me? Okay, well, I better do something about that. Those are free bits of advice. So I think all this organizational level adaptive capacity is reasoning. It's things that all of you have demonstrated that you can do. So I'm sure it could happen. A lot of companies could do this. So that's it. So the summary, I did talk briefly about these ISO standards. I'm a big fan of them. Yeah, bias, yes, I worked on some of them. And we're working on now, as I mentioned, 14,090 and 14,091. Probably by the end of the year, will be CSA standards. They'll be adopted for Canada. And they've been Canadianized, if you will. There's all kinds of references that make it more suitable for a Canadian standard. But the original standard's still there. It hasn't really changed. So those two standards, and the 14,092 is more like a case study of how it applied, how you could apply it to a local government, like a department or a city or, that kind of organization. And 5 case studies, including one from Vancouver and 4 others. I don't remember. CARMS, I didn't mention it specifically, but as I mentioned, this book, chapters 8 and 9, talk about the CARMS. We call it CARMS. It stands for Climate Action Resilience Management Systems. It's climate action. It's like a ISO 14001. As a matter of fact, that's where we got it from. We started with ISO 14001, and we said, supposing you didn't talk about environmental aspects, but you talked about climate aspects. Okay. And then we said, how does that work? And anyways, we ended up developing this template that any organization could use. It's just a starting point, right? I'm not saying it's great, but it's good enough. It helps you get going. Like if you've ever been tasked to do something, and if you have a white piece of paper, you go, that's a little harder. But if there's a straw man there, oh, okay, you just kind of fill in some blanks, change this. No, this doesn't apply. Yeah, this applies. This is good. So that's what you get out of it. So this book tells you how to develop that for your organization and how to implement it. And it also tells you how to get a free copy of a template that we made that's on our website. You know, you can go to a certain place and get a free copy. So that's CARMS. And it'll help you do that organizational adaptive capacity. I'll get you started. So what we talked about today was screening level. That's the screening level. You're starting with nothing, right? You didn't know anything about this before you came in here? Well, now you have a pretty good idea what a fire hall in Manitoba, you know, with climate change might have to go through, right? And by inference, you could say, yeah, I can imagine that's not too different from a city office in Calgary, right? Going to be in that ballpark, at least. You could think about my home. You could think about my home. Oh yeah, we're in the prairies too. Some of these things could happen to us. So I think it's very applicable, a very, very good tool. It doesn't take long. You could almost make it a game, you know, play it at home. Screening level assessments at home. Okay, I don't know. I'll talk to one of the game companies about that. Enhancing organizational capacity, that's what we're trying to do, just a little bit better. Thinking, being aware, doing a few things, trial and error, really, but continually improving. So that's what we talked about. I hope it was a helpful workshop. Yeah, so any questions? Anything you'd like to talk about before we wrap up? Just got a few more minutes, but yeah, go ahead. I will bring a microphone in. By the way, I hope do you agree with my premise that you now can do your own screening level risk assessment? Yeah, I see some nods. Yeah, good. Yeah, you could do that. It doesn't mean you don't have to hire a consultant anymore. They can take you a lot further, but yeah. Go ahead, please, the question.
First off, thank you so much for your presentation. It was really insightful. I'm just wondering, for those folks who want to pursue, you know, further develop their knowledge in conducting climate risk assessments, given your, you know, years of experience in the field, are there any sort of certifications that you would recommend? For example, like, you know, a certificate from the Global Association of Risk Professionals or similar certifications?
Yep, good point. As a matter of fact, maybe Eco-Canada could have a EP brackets climate change adaptation or climate change risk assessment. I think that's a great idea. I'd like to pitch, maybe I have even pitched that. Sabrina, did I pitch it to Eco-Canada? Yeah, I mean, that's one possibility, but yeah, any of those other organizations maybe as well. I don't know of any, I mean, there's certification for people like that, but I don't think in particular, it's like for a climate change risk assessment. I'm not aware of any. One thing you can do, you can get Infrastructure Canada. Yeah, I don't know. Anyways, they have the Climate Lens. They publish the Climate Lens. You can read that. It's a guidance document, something like 40 or 50 pages long, relatively understandable. Like, it's not a lot of jargon, a little bit of jargon, but not too much. It's readable. And it's a guide, right? It tells you do this, and that. And that's actually all we did. We just followed the steps. You know, the first one we did 8 or 9 years ago. Oh, okay, let's see what it say. Yeah, we do this. Yeah, so you could, that's another way. I don't know of anything else. But I think maybe a good way is like Eco-Canada. They're already doing all kinds of different certifications, right? Why not add on another one? As a matter of fact, I think they're working on the greenhouse gas, the quantification one. And speaking of that, just as a shameless advertisement, tomorrow at this same time in this same room, 1:30 to 4:30, we're doing a greenhouse gas management workshop. It'll be like this. The slides were prepared by Eco-Canada, or Eco-Canada had them developed. But it's going to be a similar kind of approach. There's some information shared. You have a chance to do 3 or 4 exercises, but it'll be focused on the quantifying greenhouse gas emissions, how to do it and different standards, and then maybe setting targets, how to reduce and things like that. So it's a parallel to adaptation. So strong mitigation is good adaptation, and maybe vice versa, right? The two overlap. But so I don't know. Yeah, if you find one, let me know. I'd like to know. A lot of people ask us that. I'd be happy to put on training courses on that too. But other than that.
Yeah, there's quite a few that exist.
Oh, there. Okay. Oh, one thing I should mention is PIVC, right? Is that one of your thinking?
Well, one of my tickets called the SDR certification through the Global Association of Christian Professionals. That's one among many. I think these days there's my voice is good. As sustainability professionals, there's a lot of certifications, right? Like environmental professionals, sustainability professionals, whether it's pursuing the EPT or the EP or whatever your niche is, right? There's an ever-growing amount of certifications. Nobody has time for all of them. So, I think as professionals engaging in professional development, people are always looking for the best ones, right? There's a lot. Some of them are really good. Some of them aren't so good. There's a lot of them.
Okay. Yeah. Well, from that, I know of one Association of Climate Change Officers. They have a training program you have to go through. You take those exams, and then you show some experience, and then you sign some code of ethics, and then you can have a CC-P designation, right? So that's one I've gone through. I know GARP is another one. They're more of the risk assessment professionals, and they have a CSR, is that what it is? CSR or CSR, I think they give you a designation. Those are the two I know that are mostly related to climate change, right? And like you said, there's others for sustainability and whatnot. Any other questions or anything? Okay, well, good. Lucky draw, okay. Yeah, it's not a hugely lucky draw. It's just a book. But Sabrina, you're going to get someone to draw. I'm going to get someone to draw. Okay, well, how about I get the first person near me? Although if you're drawing, then maybe, is your name in here? Is your card in here? Oh, okay, good. You can draw. So there's a few people who didn't have a card, but they have like a piece of paper. That's quite all right. Don't prejudice. You could take a card or a piece of paper, and you take one, and I'll read it out, and you guys can come up and get your book. Sorry, I should come by. Right? Sorry. Yeah. Let's see. Sarah.
Objection.
Oh, what?
I think the likelihood of picking a car is higher than
A piece of paper.
So it should be one piece of paper, another one car. That makes sense.
I think there's more cards than people. Well, there's quite a few pieces of paper too. All right, how about that? Then the next one has to be a piece of paper. Okay, Sarah Lemason? Oh, yeah, come on up and you get a book. Yay! Wow, better put that in. Yeah, yeah, grab another one, a piece of paper this time. Thank you. Congratulations.
There's a lot of cards in here.
But you're picking a piece of paper this time. Paper. Yeah, one paper.
This one paper? Okay. Oh, yeah, this is one paper.
Karen Wadhwani. Oh, Karan. Oh, yeah, maybe. Okay, good. Come on up. Give you a book. Yeah, you're welcome. Congratulations. Okay, card.
Card?
Yeah, another card. Yeah, we got 4.
Oh, 4.
So I won't bore you too much. Okay. Giseline Carl? Gazeline, okay, yeah. Sorry if I didn't get your name right.
Yeah,
You're welcome.
you.
Congratulations. Oh, now a piece of paper.
Piece of paper.
Dola Patel? Oh, good. All right. All right. Well, congratulations there. Hope you enjoy it. Yeah. Thank you. Okay, so that's the lucky draw. But you know, actually, if you go onto any of your favorite e-book things, you know, you find it's not a lot of money. And as I said, what royalties go to a solar project in Africa, which I think is, you know, that's a good cause. But it may need a lot of purchases. Okay, that's it. And we sell them on our website too. But yeah. So, anyways, you've got the information. By the way, there's about 8 or so. Yeah, something like that. 8 paper copies of the slides, right? So they're all here. If anybody wants to pick one up, you can just come over and grab it. So I'll put it here. And if you didn't get one and you'd like a copy, you could email me, right? So you have my email, and you can figure that out. So email me. We'll email you a PDF of that. And that's about it. We'd love to help. I'm quite passionate about the topic, so I'd be happy to talk about it anytime. So you can also reach out if you want to have a virtual meeting or something like that. So thank you very much. And that's it. Q&A.